Hello students, my name is Professor Muhammad Asim and we are doing ADMath for IGCSE students which have syllabus code 0606 and for CIE O level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, in last lecture we did 4 questions from exercise 13.2. Question number 9, question number 10, question number 11 and 12. So after question number 12, 3 questions are left. The topic of this exercise is position vector. Today we are going to do all remaining 3 questions of this exercise. But before I start, I would suggest all those students who are new in my channel, kindly go to my playlist. There is a folder, name is ADMath. Watch previous lectures of this exercise. After watching previous lectures, you will have good command on this topic. Let's start a very important question number 13. Relative to an origin O, the position vectors of A, B and C are, so here OA is given minus 2I plus 7J, OB is given 2I minus J, OC is given 6I plus lambda J. Part A. Find the value of lambda when AC is 17. AC means the magnitude of AC. So first we have to find the vector AC, which is equals to OC minus OA. OC is given 6I plus lambda J, minus OA is given minus 2I, so it will be 2I plus 2I and plus minus 7J is equals to 6I plus 2I is 8I. Taking common J from J terms, so it will be lambda minus 7. Now find the magnitude of AC. So 8I plus J multiplied by lambda minus 7, the magnitude is 8 square plus lambda minus 7 whole square root. The magnitude of AC is given in part A, that is 17. 8 square is 64 plus lambda minus 7 square. It will be lambda minus 7 square remains square root. Taking square on both sides, so it will be 17 is equals to plus minus 64 plus lambda minus 7 whole square. Okay, so first we have to take the positive value. 17 is equals to 64. Sorry, I forgot to put squaring on both sides. So 17 square is 289 is equals to 64 plus lambda minus 7 square. 289 minus 64 is equals to lambda minus 7 square. 289 minus 64 is 225 is equals to lambda minus 7 whole square. Taking square on both sides, so it will be 225 is equals to lambda minus 7, 225 square root, so it will be 15 is equals to lambda minus 7, or 15 plus 7 is equals to lambda, or lambda is equals to 22. So don't put this plus minus sign over here, we have to put plus minus sign over here. So plus minus root 225, one is 15 plus, and next is minus 15 is equals to lambda minus 7. So minus 15 plus 7 is equals to lambda. Lambda is equals to minus 8. Hence lambda is equals to 22 or minus 8, because minus 15 plus 7 is minus 8, sign of the bigger number. So students, this is the answer of part A, where this question is very important. Part B, find the value of lambda when ABC is a straight line. So when ABC is a straight line, it means we are talking about parallel vectors. This is part B. So because there is no relation between part A and part B, so I am going to rub part A first, then I will do part B. Okay. So part B is find the value of lambda when ABC is a straight line. It means AB and BC are parallel. So if two vectors are parallel, then they are multiple of each other. So there should be the multiple or the constant. I have put it H. You can put K, no issue. What is AB? AB is OB minus OA is equals to H time. What is BC? It is OC minus OB. OB is given 2I minus J, minus OA is given minus 2I, so it is plus 2I minus 7J is equals to H time. OC is given 6I plus lambda J, minus OB is given 2I minus J, so it is 2I minus plus J. Now simplification. On left hand side, 2I plus 2I is 4I, minus 7J minus 1J is minus 8J. H into 6I minus 2I is 4I, taking common J from these two terms, so it is lambda plus 1. Hope you understand. Now multiply this H by the whole bracket, so H into 4I is 4HI, H into J is HJ lambda plus 1. Now compare the coefficient of I on both sides. So 4I, 4 from left hand side, 4HI, so 4H from right hand side. 4 cancel by 4. The value of H is 1. Now compare the coefficient of j, minus 8 from left hand side and h into lambda plus 1 from right hand side. So minus 8, h we have already find 1, lambda plus 1. So minus 8 is equals to lambda plus 1, or lambda is equals to minus 8 minus 1, lambda is equals to minus 9. So this is the answer of part B. Lambda is equals to minus 9. So very important question, question number 13. Now move to next part, part C. What is part C? Find the value of lambda when ABC is a right angle triangle. This part is little bit lengthy but very easy. ABC is a right angle triangle, so it means angle 90 degrees should be at B, because uh, the mid letter is B. So ABC. We have to find the value of lambda when ABC is a right angle triangle. So first we have to find all three vectors, that is AB, BC and AC. So first we have to find AC. AC is equals to OC minus OA. OC is 6i plus lambda j, minus OA is minus minus plus 2i minus 7j. 6i plus 2i is 8i, taking common j, so it is lambda minus 7. So this is the vector AC. Now find the magnitude of this vector. AC is equals to 8 square plus lambda minus 7 square root. So AC work has finished. Now I am going to find out the vector BC. So it is OC minus OB. What is OC? 6i plus lambda j minus. What is OB? 2i minus minus plus j. 6 minus 2i is 4i, taking j is common from j term, it is lambda plus 1. So this is vector BC. Therefore magnitude of BC is 4 square plus lambda plus 1 square root. Now I am going to find out the third vector, that is AB. AB. AB is equals to OB minus OA. OB is given in question 2i minus j, minus OA is given minus minus 2 plus 2i minus 7j. So 2i plus 2i is 4i, and minus 7j minus 1j is minus 8j. Therefore the magnitude of AB is 4 square plus minus 8 square root. 4 square 16 minus 8 square is 64. 16 plus 64 is square root of 80. Now we have find all three vectors magnitude. Now this is a right angle triangle, so we have to apply a very well-known triangle, right angle triangle, that is Pythagoras theorem. What is Pythagoras theorem? Square of the hypotenuse is equals to sum of the square of other two sides of a right angle triangle. AC magnitude we have find 8 square plus lambda minus 7 square square root. AB magnitude we have find 80 square root square. Sorry, I forgot to put square on left hand side. BC magnitude is 4 square plus lambda plus 1 square square root and whole square. This is Pythagoras theorem. Square and root cancel. 8 square is 64 plus lambda minus 7 whole square. Apply a minus b whole square formula. A square minus 2ab. 14 lambda plus 7 square is 49 is equals to square and root cancel. 80 plus square and root cancel. 4 square is 16. Lambda plus 1 whole square is lambda square plus 2 lambda plus 1. Now see carefully, this lambda square cancel by this lambda square. 64 plus 49. 64 plus 49. 64 plus 49 is 113. 113 minus 14 lambda is equals to 18, 16 and 1. Sorry, 80, 16 and 1. It is 97 plus 2 lambda (113) minus 97 is equals to 2 lambda plus 14 lambda. 113 minus 97 is what? 16. 2 lambda plus 14 lambda is 16 lambda. 16 cancelled by 16, hence the value of lambda is 1. So this is part C of question number 13. Now whole question has done successfully. This question is very important, can come in your main exam, in your CIE exam. But if you feel any difficulty, no issue, I will help you. So this is question number 13. Now move to question number 14. Question number 14 is relative to an origin. The position vector of A is minus 6i plus 4j. So it is OA is equals to minus 6i plus 4j, and the position vector of B, it is OB, is equals to 18i plus 6j. C lies on the y-axis and OC is equals to OA plus lambda OB. Find position vector OC. Very easy. If C lies on x-axis, this is the main line. C lies on y-axis, sorry. So if C lies on y-axis, then the vector OC must be equals to 0I plus hj. Why 0? On x-axis, on y-axis the value of vector I is 0 and the value of vector j is we don't know, so we have written h. Okay, now the condition is given OC is equals to OA plus lambda OB. So OC given is 0I plus HJ is equals to OA is given minus 6I plus 4J plus lambda into OB is given 18I plus 6J. So minus 6I plus 4J plus 18 lambda I plus 6 lambda J. Taking I is common, so minus 6 plus 18 lambda. Taking J is common, so it is 4 plus 6 lambda. Now it's a time to compare the coefficient. On left hand side the coefficient of I is 0 and on left hand side the coefficient of I is minus 6 plus 18 lambda. So 0 is equals to minus 6 is equals to 18 lambda and lambda is equals to minus 6 must be plus 6 on other side 6 upon 18 1 upon 3. The value of lambda is 1 upon 3. On left hand side the coefficient of j is h. On right hand side the coefficient of j is 4 plus 6 lambda. So h is equals to 4 plus 6 lambda. Lambda we have found 1 upon 3, 3 to the 6, 4 plus 2 is 6. Hence the vector position vector of OC is 0I plus what we have let hj. H we have find 6, 6j. So 0I plus 6j or you just write 6j is same. So this is very important question and very easy according to examination point of view. Move to question number 15. Question number 15 is relative to an origin, the position vector of P is 8I plus 3J. So it is OP. 8I plus 3J. And the position vector of Q, that is OQ, minus 12I minus 7J. R lies on the x-axis and OR is OP plus mu OQ. Find OR. Position vector. OR means position vector of R. So again a very easy question. This time R lies on the x-axis. Therefore position vector must be Ki plus 0j, because on x-axis the vector j is 0. Now according to condition, OR is equals to OP plus mu OQ. OR is Ki plus 0j. OP is given 8I plus 3j plus mu multiplied by OQ is given minus 12i minus 7j. So 8i plus 3j plus minus minus 12 mu I minus 7 mu j. 8i taking common I, 8 minus 12 mu plus j, taking j is common, 3 minus 7 mu. Now first comparing the coefficient of j on both sides. On left hand side the coefficient of j is 0 and on right hand side the coefficient of j is 3 minus 7 mu. So 7 mu is equals to 3, mu is equals to 3 upon 7. On left hand side the coefficient of I is k and on right hand side the coefficient of I is 8 minus 12 mu. 8 minus 12 mu we have find 3 upon 7. 8 minus 12, 3s are 36 upon 7. 8 7s are 56. 56 minus 36 is 20, so it is 20 upon 7. Hence vector OR, what we have let ki plus 0j. So k is 20 upon 7, I plus 0j. This is our final answer. Or you can just write 20 upon 7i. So no issue if you write 20 upon 7i or if you write 20 upon 7i plus 0j, you will get full marks. So students, this is exercise 13.2. Today we have successfully finished remaining questions of exercise 13.2. Little bit lengthy but very important. We have done all questions just like we did in previous chapters, all parts with understanding. What is next? What next? 13.3 vector geometry. Very easy. How many questions? 1 2 3 4 5 6 7 8, and the last one is constant velocity problem. No issue students, I promise you I will do these two remaining exercise with each and every question, with each and every part. I request all of you kindly do subscribe my channel, and whenever you subscribe don't forget to press the bell icon button so that when I upload my videos you will get the notification. Kindly share my videos as many as you can for all those who are struggling in add math. That's it. Okay students, good luck for next lecture.